Morning science fans, morning space fans, morning all fans of everything. Shout out to the thrust and the vacuum crew, it's been a while, through your cellular, and the flat earthers, welcome, welcome. Everybody's welcome here, right? We're not going to hold anything against anyone because we're all in the same boat. Shouldn't be bickering amongst each other, should be bickering about what's going on, okay? Joseph Legrange, we're finally here. We've dug out some stuff, madre mia. Dug out some stuff. Joseph Legrange, 1736 to 1813. In 1772, the three-body solution, right? The three-body solution. What is the three-body solution? What is this fascination with Legrange, right? Well, let's have a look. What we have, it's called the three-body solution. You've got two large masses, Sun, Earth, and when you have two large masses like this, you get 5 special spots. That's what they call them, special spots, right? L1, L2, L3, L4 and L5. Now at these 5 spots, the gravity pull of these two large masses somehow cancel each other out. So when you put the third smaller mass, the third body, in these spots, it gets a free piggyback ride. Alexa, can you explain the Legrange points in space, please?
From Quizlet.com. The Legrange points, labelled numerically, are positions in space where satellites can be placed in stationary orbits relative to two larger objects, such as Earth and the Sun.
There you go, right? Earth, Sun, the 5 Legrange points. You can put a third object and it piggybacks. Like, no need to worry about fuel that much. It's just a stress-free zone. Like when you, in the future, when you rocket off to your Mars vacation, the Legrange points will probably be jam-packed with spacecraft, with people, you know, stopping for a coffee because you piggyback. You piggyback, isn't it? Some people might even go on holidays there. Let's go to Legrange 3 for the weekend. You know, get into some trouble. Legrange 1, you know. Right, so what we have here are 9 books. Right? We're going to start right hand side, it's 2013. On the very left hand side, that popular science, it's 1961. Right, so we've got, what's that? 61, 39, 49, 53. So 53 years, that 54 years, right? Between there to there. So we've got 2013, 2003, 1991, 1990, 1985, 1979, 1978, 1971, 1961. Now, we're going to start at the top and we're going to work this way because we want to know what has been said about this guy lately. And as we work back, we get a picture of what Legrange is about. Like if it was Einstein, they'd be telling us, I don't know, that he just discovered relativity and then, you know, he did his calculus but with Legrange, how many people have heard of Legrange? This is the thing. How many people have actually heard of him? Well, that's a bit bright. Right. Up until lately, is what I'm saying. Right, what kind of angle have we got here? All right. 2013. It's only going to be a few lines out of each one. It's not going to take long, right? Spacebook, from the beginning to the end of time, 250 milestones. I've gone through all the books, and these are the only ones where I can find Legrange. So we go to the index at the back, find the name Legrange, and then read what we find. Okay. With his 1687 publication of the Principia, Isaac Newton had expanded Kepler's laws of planetary motion. Straight away, the gang, isn't it? Newton, Kepi, right? It's always the same bunch, right? We'll come down here. The first to successfully solve one particular case of the three-body problem was the French mathematician Joseph Louis Legrange, who predicted in 1772 that there should be 5 special places in any three-body system that has 2 large masses and 1 small mass where the gravitational forces among the bodies would be balanced. All right, so the 2 large masses balance out, and this third cookie can just hover, kind of a thing. These places are now called Legrange points. Lagrange's prediction was verified with the 20th century discovery of the Trojan asteroids, which are trapped in the L4 and L5 Lagrange points of the Sun-Jupiter system. Now listen, I did not know this, right? And that is something that I haven't followed up. Trojan asteroids. Not for now. There you go. Somebody else might want to have a little investigative science thing. The Trojan asteroids between Jupiter and the Sun. There's Lagrange points, 5 of them, and there's Trojan asteroids. So there you go. And that was with the 20th century discovery. So that is in the 1900s. All right, because that is the 20th century. The 1900 is the 20th century. The 20th, the 21st is the one we are in now. Even though it's the year 2023, we're actually in the 21st century. So at the end of it, it will be, boom, the end of the 21st. And we go into 21, which is the 22nd century. That can be confusing sometimes. So we are now in the 21st century, right? The beginning of it. So that was Lagrange points there in the first one, 2013, right? Now this one's a quick one, 2003. It's on an Australian publication. There's no Lagrange in there. All of the guys are in there. Copernicus, Galileo, Brahe, Kepler. I did not find Legrange in there. I didn't read it all, but what I did read are the parts where you think, you know? So, but I can't quote myself there because I haven't read it all, but he's not where I thought he would be. Now this little dancer, oh, far out. I'm gonna try not to get distracted, right? I'm coming back to these. All right, these are far out. Talk about taking a trip down a garden path. Oh, far out. Now, this is 1991, right? This book. So what we've got, in the tumultuous years following the 1789 revolution, the French Academy of Sciences was at last allowed to carry through a reform that it had been urging for many years: the establishment of a simple, logical system of measures. This was desperately needed to simplify international trade, but even within France itself, measures varied widely from one locality to another. A committee which included 2 esteemed scientists, chemist Antoine Laurent de Lavoisier and mathematician Joseph Louis Legrange, agreed that to make calculations easier, the new system should be based on the number 10, and that the basic unit, etc., 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 1793, the metric system. Okay, well done, Legrange. He did it again, right? Now, that was 1793, wasn't it? Look, I mean, this guy's been going I'm pumping out the stuff, right? It was. Yeah, 1793. 1990, Funk and Wagnall, New Encyclopedia. We go to the index, we find Legrange. And what do we have? Where is he? Legrange, Joseph Louis Legrange. French mathematician and astronomer born in Turin, Italy, and educated at the University of Turin. He was appointed Professor of Geometry at the Turin Military Academy at the age of 19. In 1758, he founded a society that later developed into the Turin Academy of Sciences. 1766, he was appointed director of the Berlin Academy of Sciences, and 20 years later, at the invitation of King Louis XVI of France, went to Paris. During the period of the French Revolution, he was in charge of the commission for establishing a new system of weights and measures, metric system. He was made professor in the newly established École Normale after the French Revolution, and under Napoleon, he was made a count. One of the greatest mathematicians of the 18th century, he created the calculus of variation, systematized the field of differential equations, and worked on the theory of numbers. Among his investigations in astronomy were calculations of the libration of the moon and motions of the planets. All right, his greatest work is Mécanique Analytique in 1788. We've got 1772. That's it, all right? Now this one, this one, look, talk about absurdities. 1985. I've been in the army for a year, right? I had no idea this was going on. Not going on, what they were saying was going on. Oh, I'm not going to get distracted. Building in space, right? Throughout the history of the Soviet, listen, these things, in 1985, they were talking about this, right? Traveling through space to colonize other worlds might not be the longest lived ambition of man, but it has certainly captured the imagination of many people throughout the centuries. It was the driving force behind popular support for Apollo moon landings, and it kept people on the edge of their seats as robots from Earth sent pictures from the surface of Mars. Now listen, right, so straight to Legrange points, right? So I looked, I go, what's this now? What? Here we go, above. The areas of the moon most likely to be mined for their metal-rich ores. The best sites on the side of the moon which faces away from the Earth, right? This is crazy. This is what they were telling people back in 1985. And that's 38 years ago. There are only two safe places known as Lagrangian libration points, L4 and L5. Their situation relative to the Earth and the Moon provides gravitational wells where an object once placed would not move. So now we're talking Lagrange points between Earth and Moon system. Right, before it was massive, Sun, Earth, and now it's Earth, Moon. Listen, I keep saying listen, but this is what they would, look. Catching the pellets of ore shot from the surface of the moon by the mass driver, see next page, decelerating next, which slowed the ore from 720 kilometers an hour to only 7 kilometers an hour. Radar controlled catching frame, radar scanners, ore collection modules which move up as they are filled. Ore modules propelled by ejecting pellets. The ore is first shot to the L2 point, then to the colony at L5. It's crazy. A colony may be many kilometers long in the form of a rotating cylinder to provide gravity. Look, they're on about, now this is in 1985. And now what is it? Quantum entanglement, traveling at the speed of light. Aunt Nellie won't age if she's... People, you have to start waking up. Artist's impression of the buckets that sling the ore into space. Look, this was going to be on the moon. Look. You cannot tell me this is normal. Look. A approximately 25 kilometres long, the mass driver track would accelerate all-filled buckets at 30 G, reaching a speed of nearly 9,000 kilometres an hour before suddenly decelerating at 100 G, causing the ore in the bucket to be hurled at escape velocity away from the moon's gravity field. When the materials reached L5, they would be caught by a mass catcher employing radar to detect the approaching ore loads at a distance of 2 kilometres. The material would have been slowed by the moon's gravity trying to pull it back. When it hits the catcher net, it would move at only... I can't do it. I cannot do it. Out of this world, out of the ballpark, out of the universe, right far out. Now, like 1985, I was 20, far out. Legrange. So this is now 1990, right? God, if people don't see something wrong here. Legrange was a French mathematician. His most famous work, Analytical Mechanics, 1788, is an algebraic study of the forces and motions involved in orbits of planets, the flow of liquids, and vibrating strings. Legrange also wrote on interpolation, probability, and number theory, and helped set up the French metric system. Legrange was born in Turin, Italy. At the age of 16, he became a professor of mathematics in the Royal Artillery School in Turin. Legrange, at the age of 16, he became a professor of mathematics in the Royal Artillery School at the age of 16. He was appointed professor of geometry at the Turin Military Academy at the age of 19. Now listen, 1960. 1960, there's a big difference there. Right, and that's it there, nothing else. 1978. See how it's kind of gotten less? $1978. Oh, this little number, look, spaceships of the mind. The deserts of space are rich in energy and materials that could support life. It will be human life by the look of things. Nice one, Nigel. Where was Legrange? There we go. It is again, look. The device propels a special bucket equipped with superconducting coils carrying a strong electric current. Each bucket rides like a surfboard on the crest of a magnetic wave generated by circular coils arranged along a guideway. Oh, and on and on. The mass driver sitting at the lunar mine will shoot the sacks of lunar material towards Legrange Point 2. The Legrange point closest to the moon, which they will reach reliably, even if there are small launching errors. Checked by the moon's gravity, the sacks will arrive fairly slowly at catcher station at L2. After collecting the lunar soil for a period of weeks or months, the catcher will travel to the manufacturing site in orbit about the Earth. The catcher will be propelled by another mass driver, but this time used as a reaction engine. It will hurl out some of the load to push the catcher along. The round trip will take several months, but half a dozen catchers will keep up a steady supply. Oh, far out. No wonder everybody's obsessed about going to Mars if this is what they were telling people in the 70s and the 80s. Jeez. Junior World, 1971, right? Now, you might think, what's it, a Junior World? The reason, right, is because it's a collection, right? And it's, even though it's junior, right? It's a hell of a collection. Now, it was only this morning or yesterday, last night, I went, let's just have a look in this. Legrange, it's there. Not Legrange, sorry, Legrange isn't there. So I thought, all of the others are. When I say all of the others, Copernicus, Galileo, Tycho, Kepler, Newton, Olaus, Roma. He's in here. Right? I'm not making this up. What is it under? Is it under it's under Roma, wasn't it? Obviously. RH. I couldn't believe it. Roma, Olaus, 658. It's, don't want to read it, but there is no Joseph Legrange. 1971, he doesn't exist now, right? Then I go to 1961. The Book of Popular Science, he's not in here either. Now these are the oldest two. From 71, maybe it was invented in 72, 73, 74. My point is, he's all popular up there now. Now, James Webb's there. But where was he back then? If anybody's got any pre-71 books, now's the time to have a look at them. Hopefully got some more on the way, but you can't say it's not a bit strange. Now this Legrange point, the crazy thing that I only found out tonight, right? How long are we looking at? 22, all right, I was thinking 25, that's good, all right. I only found this out tonight. Alexa, what is the James Webb Space Telescope doing at Legrange Point 2?
From techmail.co.uk. The James Webb Space Telescope is currently orbiting at Legrange Point 2, where it will remain for the rest of its working life.
Hear what she said. It's orbiting Legrange Point 2. It isn't in, it isn't at, it isn't piggybacking, it's orbiting. Now what is there to orbit? There is no mass, is there? It is supposed to be the third body, but instead it's orbiting. What? How? What is it orbiting, right? It's in elliptical orbit when it's the closest to the Legrange Point 2. It's 250,000 kilometers away. When it's at its furthest, it's 830 kilometers away, 830,000 kilometers away. So basically, this thing is going, but what is it orbiting? What is it? What mass is there here? How can it orbit? I mean, anyway, there's Daisy the cow. NASA, when they launched it, they reckoned it would have about a 8 to 10 year life. It had such a good trip out there, they're going to pump 20 out of it, they reckon. That means 40. All right. Another strange thing about this, the closer the planet to the sun, the faster they orbit. So Mercury's like this. All right. Venus, a little bit further out, is a little bit slower. Earth, a little bit slower again. Because the further out from the sun you are, the slower the orbit. Obviously, when we get to Pluto, it'll be, all right? But the James Webb, because it's here, it's managed to lock in at the same speed as Earth. So it's going faster because it's further out, but it's going at in the same orbital period, shall we say, like a year to orbit the sun. And it's 1.5 million kilometers out. So there you go. Now you know about Legrange and what he discovered in 1772. All of these things, I mean, there's coincidence and then there's just, ever think about this? Just like the pictures stand back a bit and just think, hang on a minute, why are all these guys pre-electricity, pre-light bulb, working everything out for you know what? La Luna. Look at it. Anyway, enough of that. That is Legrange. Drop a comment. If you have any books, pre-1971 science books, have a peek. You might have a friend, your granddad, somebody might have these books, right? Have a look. Drop a message. Pre-1971. 72, 72, 73, 74, 75, 76. I'll be back with some serious absurdities out of that book. This, you guys are living on science, you're in a science fiction movie. The kids are growing up believing this stuff, and they were growing up 30 years ago believing that there was going to be factories on the moon slinging sacks of minerals. Anyway, 27 minutes, that's plenty. Hasta la vista.